Hi, good morning, y'all. My name is Maura Kelly, and I'm a director of engineering at Intuit. It is great to have you all here in my city. I am sorry we could not order better weather. So I work on Mailchimp, and my teams kind of keep everything running smoothly. I actually noticed that they were responding to alerts in their Uber on the way to the conference this morning. And today, I want to tell you a little bit about how we moved Mailchimp onto Intuit's developer platform, which is built on many of the open source technologies that we're here talking about at this conference. So Mailchimp is an email and automations platform, and we have 11 million users sending about 700 million emails every day. We were founded in 2001 right here in Atlanta, and this is some pictures of our new office, which is about 10 minutes from here. About 4 years ago, Mailchimp was acquired by Intuit, and we joined a family of recognizable brands, TurboTax, Credit Karma, and QuickBooks. And we also joined a company very active in the open source community, from winning awards to creating the Argo project. So as you can imagine with any acquisition, we faced a number of tech challenges. We had additional compliance demands with being part of a publicly traded company for the first time. We knew that we wanted a way to bring our products together more easily. And we didn't yet have a standard development platform for our services. We were deploying them in different ways. Some were in the cloud, and some were actually still on bare metal. Luckily for us, Intuit had already solved a lot of these problems with their development platform. So what did we do? A big tech migration, of course. We started with our biggest project, our 20-year-old monolith. Remember those 11 million users I told you about? They are largely served by this code base. A joint team from Mailchimp and Intuit, some of whom are here today, moved the monolith onto the Intuit platform. Thanks to the great work of this team and the rock-solid technologies underneath, most developers did not even notice it was happening. We also moved some of our existing microservices and even built some new services on the platform. It's great to be coming onto a proven platform. It supports highly available services, boosts developer productivity, and things like compliance, security, and operational excellence are built in. This lets developers focus on building new customer features and spending less time worrying about managing infrastructure. So wrapping up, if you find yourself in a similar position, here are some of my takeaways. First, we have this idea at Intuit called Done For You. So if you know that all of your services have to have certain things, build it in, make it part of the platform, do it for your developers. Second, of course, build only what you have to. Use open source where possible, and give back to keep the community moving forward. If you would like to talk more, I will be at the Intuit booth later today. Thank you so much.
Good morning, everyone. I'm Steve Bauer. I lead the Cloud Native Compute Services group at Bloomberg. Our team provides a wide range of compute platforms, supporting everything from analytics to AI. I've been at Bloomberg myself for 13 years. I spent my career before that building search engines. Oh, let me go back. Sorry. There we go. Sorry. I've always been drawn to building large-scale distributed systems. And more importantly, making them accessible for engineers. Bloomberg's Kubernetes story started in 2016 when Kube 1.3 was just released. Containers were new, Kubernetes was even newer, and everything carried real risk. At the time, we were looking for a new control plane for our Apache Solar infrastructure, and we saw Kubernetes as a potential solution, even though it was still pretty early. To de-risk, our adoption of Kubernetes, we started using it for our AI engineers to support their model training and data exploration. Workloads that didn't really require an SLA, strict SLA. We even built our own third-party resources. You can see an example up there. Before CRDs existed, it was hard work, but it actually taught us how extensible Kubernetes could be. When we met the Kubeflow community here at one of the KubeCons, we realized that the open source community would quickly eclipse the work that we were doing internally, and it made far more sense for us to build in the open rather than in parallel to it. This conference, this community is exactly why that matters. In 2019, we started building our own inference service internally, and we came to KubeCon in, I think it was San Diego, and in the hallway track, which is one of my favorite parts of this conference, our discussions turned to inspiration. We realized that everyone, from the people that we had been collaborating with on Kubeflow to the people using Kubeflow, wanted a scalable, reliable inference solution. We went home energized and immediately got to work refactoring our code base, which initially became KF Serving, and more recently Kserve, which recently graduated as an incubating project in CNCF. That experience, experiment internally, validate, and then work in the open, has really shaped how we approach technology. As Kubernetes matured, so did our ambitions. We built platforms not just for inference, but for stream processing and batch analytics. Today, our infrastructure spans thousands of Kubernetes nodes in the private cloud and in the public. We work closely with the CNCF and other open source communities, giving back to dozens of projects. For us, platform engineering is as much about shared practices and lessons as it is about the actual technology. Now, in the age of agentic AI, workloads are no longer static deployments. They're dynamic reasoning systems that need a new orchestration layer. As AI traffic began to surge, Bloomberg's AI engineering organization developed an AI gateway to safely manage and route traffic. Those lessons and the community outreach that we did based on that led to the Envoy AI Gateway, which we kicked off last year with Tetrate, bringing Envoy's proven strengths to AI inference and agent communication. At Bloomberg, we've always believed that the best way to build sustainable infrastructure is to build in public. From running Kubernetes 1.3 back in 2016 to helping shape Kserve and now helping to define the AI Gateway standard, we've tried to stay ahead of the curve, but always side by side with the community. So as the CNCF ecosystem enters this new era, where platform engineering and AI infrastructure converge, we're excited to keep building with all of you. Thank you.
All right. Hi, folks. My name is Adam Kocoloski. I am an engineer working at Airbnb's infrastructure, and I'm delighted to speak with you for a few minutes today about how CNCF projects enable our platform engineering efforts. So, in the nearly 20 years since Airbnb's founders welcomed the first guests into their San Francisco apartment, we've had a front row seat into the evolution of the world of cloud-native computing. We were one of the earliest companies to build directly on AWS, back when you could count the number of offerings in the service catalog on one hand. In the beginning, the Airbnb backend was a big Rails monolith. That worked for about a decade, and eventually, as the company grew, we found it increasingly challenging to continue to ship and maintain software at high velocity and high quality. And so we embarked on one of those monolith to microservices transitions that you hear so much about. We were early adopters of Kubernetes and Istio, and over a period of a couple of years, built out a full services tech stack. If I fast forward to today, our leadership talks a lot about perfecting the core, and I think that pillar of our strategy applies equally well to our tech stack as it does to other parts of the business. And so I want to give you a quick tour of how some of the extended elements of the CNCF landscape are helping us execute on that pillar of our strategy. So let's start with scheduling and orchestration. Kubernetes powers all of our online services today, as well as an increasingly diverse set of other workloads. If you'd like to hear about our experiences running production Spark jobs on Kube, come check out my colleague Damon's talk tomorrow morning. And our scale, improvements in scheduling and allocation efficiency, taking full advantages of opportunities for auto-scaling, and selecting the right instance mix for our workloads are all increasingly important opportunities for optimization. And we've been really happy with Carpenter as a big upgrade for us on that front. Now, all of those pods throw off a ton of telemetry, and we have just concluded a migration that gets us to the point where all of the signals that we collect from that stack are stored and queried using an open source stack powered by projects like OpenTelemetry and Prometheus. Now, that stack's important for us to manage our costs, and that's great. But what excites me as an engineer as well is the opportunity that we have to build more and more intelligent consumers of that data. And that's something we can only really do because of the power of this ecosystem, as well as the control that it affords us over the full end-to-end data pipeline for that data. Moving on to CI/CD. So I mentioned that was one of the main motivators for our rebuild of our tech stack in the first place. We continue to invest in deployment capabilities. Adding blue-green, frankly, is a long overdue enhancement to our pipelines. But we've been really pleased with the Argo project and Argo rollouts in particular in the way that it's able to implement these capabilities, I would say, with the grain of core Kubernetes primitives. So that's been an exciting enhancement for us. One of the early adopters of that functionality at Airbnb is our Viaduct sort of central system for accessing Airbnb backend data through GraphQL. It's a project that we recently open sourced, and I'd encourage you to check it out. So these deployments give us an ability to limit the blast radius of any bad change, as well as really accelerate the rollback. Some of our services have complicated deployment pipelines. Blue-green significantly reduces our mean time to mitigate in those sorts of incidents. And of course, all of these services need to talk with one another. They need to take in traffic through the front door. As I said, we were a very early adopter of Istio and Envoy, and these days we're looking forward to the opportunities afforded to us by projects like Cilium to unlock new capabilities in our networking stack. Now, the organizers also said they'd love to hear a little bit about the intersection of AI and platform engineering, so let's do a quick teaser there. I would like to say that Airbnb has been at the leading edge of employing and enabling our developers to use leading AI coding tools. But it was really the introduction of our agentic CLI earlier this year where adoption totally took off. These days, a majority of Airbnb developers are also active users of our agentic coding tools for a wider variety of tasks. And we've seen, in particular, companies like ours have a long backlog of migrations, a never-ending backlog. And AI assistance in this front has been particularly powerful. Looking ahead, we've got MCP tools sprouting up all over infrastructure to enable smarter interaction with our platforms. And in particular, I think we see a lot of opportunity for agents to improve incident triage and accelerate root cause analysis, using our telemetry signals and then providing sort of a ride along in our incident channels. But at the end of the day, we work with all of these projects so that we can enable our developers to write better software and run it more effectively. And that's software that enables that provides the opportunity for human beings to connect with each other and with communities in the real world. And if that's the sort of mission that excites you, I'd love for you to maybe reach out. Thank you.
Good morning, everyone. Hello, Atlanta. My name is Liguang from ByteDance infrastructure team. Today, I'm going to share the open source journey of AI Bricks, a project born from one simple but ambitious idea. Can we run Gen AI inference workloads as cloud-native, scalable, and efficient as microservices? When we first started AI Bricks within ByteDance, our challenge was simple to describe but incredibly hard to solve. How do we run AI inference workloads across thousands of AI accelerators, regions, or even in different clouds, all in a Kubernetes native way? After years of development, AI Bricks has evolved into a production-grade platform that orchestrates AI inference workload at a massive scale. By the end of this year, AI Bricks will power thousands of AI accelerators across ByteDance global infrastructure, serving both large language model and multimodal models around the clock. But what makes the story really special is what happened after we went open source. Since its release early this year, AI Bricks has exploded its community growth. Over 4,000 GitHub stars, nearly 100 contributors. And here's my favorite part. Over 80% of our contributors are now from outside ByteDance. This is the spirit of open collaboration, a diverse global effort to build the foundation of cloud-native AI. At its core, AI Bricks is Kubernetes native distributed inference stack for running large model inference reliably and efficiently. It's designed for openness and interoperability. We do support multiple hardware vendors, from NVIDIA, AMD, to AWS inferential AI chips, to Huawei ASL. We also support multiple open source models, multiple inference engines, from VLM, SGLang, XLM, and beyond. And its core, AI Bricks, is a fully extensible architecture with pluggable modules for customer routing policies, preview, decode, disaggregation, and KV cache backend. So put it all together, AI Bricks bring production-grade deployment, elasticities, observabilities for large model inference, making Gen AI serving not just powerful, but truly cloud-native. As AI Bricks embrace the Kubernetes AI ecosystem, we are collaborating with projects like Volcano, Inference Perf, and will actively participate in the new AI Conformance working group to build a shared open standards for AI inference. So our goal is very simple, to make the future of AI infrastructure open, composable, and community-driven. So today, I'd like to invite all of you, developer, researcher, and operator, to join us on this journey. Let's build the next generation of cloud-native AI infrastructure together. Thank you.